Hello dear students, in this module we'll learn about the simple pendulum, motion and types of motion. So first of all we'll take measurement of time using periodic motion. Now the question arises, what is periodic motion? So the periodic motion means the motion of an object which repeats itself after regular interval of time. Here you can see the example: rotation of earth, revolution of earth, motion of a needle in the clock. Some more examples are here: motion of a swing, vibrations produced in a stretched rubber bands when plugged, motion of a pendulum. So all these are the examples of periodic motion. See, he is a Galileo. Now what does he do? Why should we talk about him? It's because Galileo was one of the earliest scientists who demonstrated that periodic motion of a simple pendulum can be used to measure time accurately. He showed that pendulum always completes an oscillation in a fixed interval of time. So this fact is used to make pendulum clocks. You can see diagram of a simple pendulum here, and you should make practice for this diagram because it may comes in your exam. So what is simple pendulum? Simple pendulum consists of a small metallic sphere. See, metallic sphere. You can say it as bob, okay? Then this bob is fixed at one end. This is nail. It is fixed at one end with a thread. Here it is thread, okay? And the another end of this thread is fixed with nail and one end is fixed with this ball. So what is bob? Bob is fixed at bob is a small metallic sphere which is fixed at one end of a thread and suspended from a rigid support. Here it is a rigid support. When this bob is pulled to one side and released, then it swings to and fro. This is called to and fro about its mean position. It is considered as mean position. Okay. Now with the help of diagram, we can see some important contents here. Mean position. Here A is considered as mean position, okay, or you can say the position of rest of the bob. Now this position B and this C, these are called as the extreme positions of the bob. When they are called as the extreme positions of the bob? During the motion of the pendulum, when it moves from here to here, okay. Now the term oscillation. What is oscillation? See, pendulum is said to have completed one oscillation. When? When it moves from A to B, from its mean position to its extreme position, B. Okay. Then through A to C and finally back to A is called an oscillation. A to B, B to A to C, C to A. That means the movement from its mean position to both of the extreme position is said to be an oscillation. Okay. Now amplitude. Amplitude means the distance by which a pendulum moves away from its mean position. From its mean position, how much distance this bob covers, so during its motion is called an amplitude. You can see here a small metallic sphere is called bob. Mean position, position of rest of the bob. Oscillation, a complete cycle of motion of a pendulum from its mean position through both extreme position and back to its mean position. Amplitude, the maximum displacement of a pendulum bob from its mean position. Then simple pendulum, a small spherical bob attached to one end of a string suspended from a rigid support. Now, what is time period of a simple pendulum? So, the time taken by a simple pendulum to complete one oscillation is called its time period, okay, and is measured in seconds, small s. Then what are the characteristics of a simple pendulum? It does not depend on the amplitude of oscillation of the pendulum. Second, it does not depend on the mass of the bob. Third, it only depends on the length of the string or the rod of the pendulum. Okay, longer is the length of the string, greater is the time period of the pendulum. Okay, let's imagine you need to visit to your relatives and you are sitting in a car and looking outside the window. You will observe that position is changing with respect to the trees, poles, banners, etc. But actually, your position is not changing. Your car's position is changing. Okay? You are sitting in the car, but your car is moving ahead. So, your position is not changing. Your car's position is changing with respect to the objects or other persons or object, okay, sitting with you in the car. But what happened to an observer who is watching you from outside the car? You and objects inside the car are in motion. If we look around, we observe that many objects do not appear to move. They are stationary. Your school, it doesn't move. Roads, they doesn't move. Poles, even stationary object, it is at rest. Houses at rest. Chairs, tables was at rest. The mountains, hills at rest. Trees at rest. Means the displacement is not there. They are not changing their positions by their own. You can see some of the examples here. See trees, houses, poles, they are rest in position, in rest. And the man playing, birds flying, and butterfly, even they fly, they are in motion. So what is motion? Motion is an object, or an object is said to be in motion if it changes its position with respect to time. Then what is rest? Rest, an object is said to be at rest if it doesn't change its position with respect to time. See some more examples for motion. Moving vehicles, children going to school, children playing on the park, and rest. Your books lying on the table doesn't change its position until disturbed by anybody else. Now comes towards the next point, that is types of motion. Some of it you know very well because you already learn it in class 6. Rectilinear motion, curvilinear motion, circular motion, oscillatory motion, random motion, periodic motion, rotational motion. Now let's see about the rectilinear motion. It is the motion in which an object moves in the same direction at a given time. Means object moves in a straight line. See linear. Linear means in a line, in a straight line. Now curvilinear motion. Curvilinear motion is a motion in which an object moves in the same direction along a curved path. Okay. See when you are playing the basketball, what you are doing, you are trying to put that ball in the basket. So which type of motion it is? It is curved motion, okay, in which an object moves in the same direction along a curved path. Circular motion. So circular motion is a motion in which an object moves in a circular path. You can see some of the vehicles, they moves in a circular, they are moving in a circular path. Oscillatory motion. Oscillatory motion is a motion in which an object moves to and fro about a mean position. See, to, fro, to, fro. Here is the mean position. So, to, fro. This is an oscillatory motion. Okay. Random motion. Random motion like not a particular motion. Okay. So, butterflies, birds, insects, they are the best examples for this random motion in which the direction of an object keeps changing. Or this type of diagram also you can say. See, this is also a random motion, right? Next is rotational motion. See, what is rotational motion? So, motion in which an object moves around a fixed axis without changing its position. See, the earth, it rotates but it doesn't change its axis. Hai na? You are playing this spinning top. So, spinning top, it also doesn't change its axis, means in a fixed axis it's rotating. Here this Ferris wheel or Ferris wheel, you can see here, it is also an example. Fan is also an example. Rotating blades of helicopter. So these are the examples for rotational motion. Now let's come towards next point, that is slow and fast motion. The concept of slow and fast motion is related to the distance covered by an object and the time taken by it to cover that distance. Means you can see here, what do you mean by slow? It is common experience that the motion of some object is slow while that of some others is fast. If you are running with your friend, then maybe you are slow in running or maybe your friend will be slow in running. So slow motion is what? Slow motion is an object covers a particular distance in more time. Fast motion, an object covers particular distance in less time. Here you can see an example. Consider a 100-meter race event. Okay, in your physical classes 2 years ago, it always happened in our school. So consider a 100-meter race event. The athlete that takes least time to cover 100 meter is said to be the fastest, while the one that takes most time to cover 100 meter is said to be the slowest. Thus, we can say that an object is faster if it covers a given distance in a shorter time than another object which takes a longer time to cover the same distance. We can see one example here. See, you just suppose these are the runners, okay? Runner A, runner B, runner C, D, E. You can take any name: A, Arif, B, Babita, C, Chetan, D, Dolly, F, Farhan. Okay, so these persons, they are taking part in race. So they have taken the time: A 20 seconds, B 18 seconds, C 30 seconds, D 25 seconds, and E 35 seconds. Okay. Then see, we can recognize here who's the faster one. Means in the shorter period of time, this, see, 18 seconds. So see, Babita, person B, it takes only 18 seconds to complete its 100-meter race. So it stood first, she stood first in rank. Okay. Then who will be the second one? He's 20 seconds. The person who covers the distance in 20 seconds will stand in second rank. Then third, 25 seconds, third rank, then 30 seconds, fourth rank, and 35 seconds last. Okay. So here we have completed the topic motion, its type, slow and fast motion.